Hi, my name is Sai Krishna. So let us look at the question number 8. In question number 8, we are given the Poisson process, and we are told that we are also given by the properties of it. So we are asked to calculate two things. One is expected value of x of t and autocorrelation t1 comma t2. So let us look at question 8 part A. So in question 8 part A, we are told to calculate the expected value of x of t. So expected value of x of t. So from definition of Poisson's process, we know that p of x equal to k is given as e power minus lambda power k by k factorial. Okay, so we also know that k, when summed up from 0 to infinity, e power minus lambda power k by k factorial must be equal to 1. We also know this. So now let us take the e power lambda to this side. Sigma k equal to 0 to infinity lambda power k by k factorial equal to e power lambda. Now differentiate both sides with respect to lambda. So sigma k equal to 0 to infinity d by d lambda of lambda power k by k factorial equal to d by d lambda of e power lambda. So here we can see that this becomes sigma k equal to 0 to infinity k into lambda power k minus 1. We are differentiating lambda power k with respect to lambda, so it becomes k into lambda power k minus 1 by k factorial equal to e power lambda. Differential of e power lambda with respect to d lambda is e power lambda. So lambda to the power of k minus 1 can be written as 1 by lambda sigma k running from 0 to infinity k lambda power k by k factorial equal to e power lambda. Now shift lambda to right hand side. Sigma k running from 0 to infinity k into lambda power k by k factorial equal to lambda into e power lambda. So divide both sides with respect to e power lambda, sorry. So this becomes k running from 0 to infinity e power minus lambda k lambda power k by k factorial equal to lambda. So we can clearly see that this is the e of x when discrete values are taken, equal to lambda. Similarly, hence we can write that e of x of t is equal to lambda t. Hence we have calculated the part A in this manner. So let us look at the part B. In part B, we are told to calculate the autocorrelation of T1 comma T2. So 8B, autocorrelation of T1 comma T2. So here we can solve this using two conditions. We can consider two conditions and solve it, where T1 is greater than or equal to T2 and T2 is greater than or equal to T1. Let this be first condition, this be second condition. Okay. First, what r of T1 comma T2 can be written as e of x of T1 into x of T2. This is known. So given that we have considered Poisson's process, we know that Poisson's process is an independent incremental process. So hence we can write it as x of T1 minus x of T2 is also independent in this case. Hence r of T1 comma T2 is equal to, here we are considering when T1 is greater than or equal to T2. We are considering the first case. So this is equal to e of x of T1 plus x of t2 minus x of t2. I'm adding and subtracting x of t2 into x of t2. Okay, now this becomes e of x of t2 into e of x of t1 minus x of t2 whole plus e of x of t2 whole square, x square of t2, so we know this, but we don't know this. So for this, let us look at the equation which we have previously considered, this one. Okay, we can write it as sigma k running from 0 to infinity k into lambda power k by k factorial equal to k into lambda power k by k factorial equal to lambda e power lambda. Now differentiate again with respect to d lambda. So sigma k running from 0 to infinity d by d lambda k into lambda power k by k factorial equal to lambda e power lambda. D by d lambda is here. Okay, so this can be written as sigma k running from 0 to infinity k square lambda power k minus 1 by k factorial equal to lambda e power lambda plus e power lambda. Yeah, so this can be written as sigma k running from 0 to infinity k square lambda power k equal to there will be 1 by lambda here, e power lambda by k factorial plus e power lambda. Yeah, I've written it. So this becomes sigma k running from 0 to infinity k square e power lambda power k by k factorial equal to lambda square e power lambda plus lambda e power lambda. Now take lambda to this side. This becomes k equal to 0 to infinity k square e to the power of minus lambda power k by k factorial equal to lambda square plus lambda. Yeah, so this is equal to, so this equation, the final equation here, this is e of x square. This is, we have calculated, this is lambda square square plus t. Hence we can write lambda of x square of t as lambda square t plus lambda t. Now substitute the calculated expected value of x square of t in this equation. Hence it becomes autocorrelation of t1 comma t2 equal to autocorrelation of t1 comma t2 equal to we have calculated expected value as lambda t, correct? So this becomes lambda t2 into lambda t1 minus lambda t2 plus lambda square t2 plus lambda t2, correct? So now simplify it, lambda square t1 t2 minus lambda square t2 square plus lambda square t2 plus lambda t2. Here it is lambda into t, right? So this becomes lambda square t2 square. So this is also square, so hence these two cancel out. So this is lambda square t1 t2 plus lambda t2. Take one lambda outside, so this becomes t2 plus t1 t2 into lambda. So now this is for t1 greater than or equal to t2. Now consider the second part where t2 is greater than or equal to t1. In this case also the r of t1 comma t2 can be written as e of x of t1 into x of t2. this can be written as x of t1 into x of t2 plus x of t1 minus x of t1, sorry. Okay, yeah. So this can be written as e of x square t1 into e of x of t1 into e of x of t2 minus x of t1. So this is equal to lambda square t1 square plus lambda t1 into lambda t2 minus lambda t1. So simplify this again, lambda square t1 square plus lambda t1 square t2 minus lambda square t1 square. Cancel these two, and we forgot this one, so yeah, so this becomes plus lambda t1. So this is equal to lambda into t1 plus lambda t1 t2. So this becomes, when t1 is greater than or equal to t2, this is lambda into t2, sorry, this is t2, sorry, I've done it wrong, t2 plus lambda t1 t2. Okay, sorry, this is for t2 greater than t1, it is lambda t1, sorry, written it correct only, sorry. For t2 greater than or equal to t1, this is lambda t2 plus t1 plus lambda t1 t2, or simply we can write it as lambda into min of t1 t2 t1 comma t2 plus lambda t1 t2. Hence in this way I have calculated the question number 8. Thank you.